Error, system, overload. Error, system, overload.
Most of us have seen this message pop up on our calculators when we type in too many calculations. On a grand scale, many current STEM problems are unsolvable because our computers would take billions of years to solve them. But what if there was a computer that could solve these problems in seconds? In fact, we may already have one. Quantum computers. Classical computers, like the one you're using right now, use bits, which are units that can be either a 0 or 1. Bits make up every piece of information on your device, like photos on your screen or videos on YouTube. While the simplicity of bits leads to the fast speed of devices, each bit can only hold 2 values of information. But what if a bit could be a 0 and 1 at the same time to hold more information? One quantum mechanics property holds the answer. Imagine flipping a coin. When the coin lands, it's either heads or tails. But when it is in the air, it could be seen as both heads and tails. This state of being both is called superposition. Quantum computer bits, called qubits, use the properties of superposition to quadratically speed up calculations. For instance, let's say you have a 4-digit password where each number can be either a 0 or a 1. A classical computer would have to run each possible combination, which would take 16 trials. In contrast, because of superposition, a qubit can be both 0 and 1 at the same time, which reduces the number of trials. Instead of the computer running 16 trials, it can run just 4. Another algorithm, Shor's algorithm, has dangerous implications in cryptography. Cryptography secures important online data, like bank passwords and medical information. Usually, important information is encoded and translated back using a key. If a hacker wanted to solve for this key, a classical computer would take thousands of years, but a quantum computer only needs seconds. But don't expect to see a quantum computer on every hacker's desk. The quantum state of qubits requires a stable, extremely cold environment, which is difficult to maintain. It's also hard to have enough qubits in the quantum state. Right now, the maximum number of qubits is around 50, but scientists hypothesize that thousands of qubits will be needed for some applications. So what is possible today for quantum computers? Currently, one use for quantum computers is to solve one of the greatest biological mysteries, modeling the structure of intricate protein molecules. Because of quantum computers' ability to quickly run through simple calculations, biologists are able to run through more possible protein structures to find the most accurate ones. A better understanding of proteins will help us create more effective medicines and treatments. In the future, quantum computers could also improve predicting weather patterns, testing neural pathways for artificial intelligence, and modeling the actions of quantum particles themselves. However, quantum computers won't ever replace your favorite laptops. They're simply meant to solve different problems. While quantum computing still has a long way to go, the possibilities are truly endless. Imagine a world where quantum computers have resolved the mysteries of medicine, weather, and so much more. Quantum computers could upgrade every aspect of our lives and make science fiction a reality.